Hello students, welcome to Learner's Planet, problem solving session 1 of carbon and its compounds. So in this topic we discussed about the types of bonds formed by carbon, also about the allotropes of carbon, the IUPAC naming or nomenclature of hydrocarbons, and also about your ethanol and ethanoic acid. So in problem solving sessions we will be discussing about the questions which can come in your exams related to these topics. This is the very first session of carbon and its compounds, very first problem solving session of carbon and its compounds. We'll be discussing very simple and very easy questions in this session. So now let's start with the problem solving session. Now here students, there is a question, dash type of bond is formed by carbon. What type of bond is formed by carbon? See, this is the question number 1, and can you guess the type of bond formed by carbon? Carbon belongs to the 4th group. Okay, so in the 4th group, as it belongs to the 4th group, how many valence electrons are there? So what is the number of valence electrons here? It is 4. Now can this carbon, I explained to you in my theory session, can this carbon form C4 plus ion? No, because it requires large amount of energy to lose these 4 electrons. Can carbon form C minus 4 ions? No, carbon cannot hold, or the nucleus of carbon cannot hold 10 electrons in its valence shell. So how can it complete its octet? By sharing of electrons. So what type of bond is formed by sharing of electrons? It is a covalent bond. So what will be the answer of this first question, students? It is that covalent bond is formed by carbon. So it should be dash bond is formed by carbon. So it is covalent bond is formed by carbon. Okay. Now let's take up our next question. This is also a very simple one. Carbon forms chains due to its dash property. Well, how it forms the chains? Chains like, say the second question, it is forming a long chain like this. So what is its property? This property. This is the self-linking property, right? So it is self-linking property. And what is the self-linking property called, students? It is called as catenation. Okay? So catenation is a self-linking property, and catenation property is present only in the first atom, that is only in carbon. It is not present in silicon or germanium or tin. The rest of the members of family or this group is carbon, silicon, germanium, tin and lead. Okay. Now these elements, they do not have what? Catenation property. So these do not have catenation. Okay. So the answer of second question would be catenation. Now see this. diamond has a rigid structure as carbon is linked to dash carbon atoms. So in diamond, each carbon is linked to how many carbon atoms? Say this is a carbon. In diamond, each carbon is linked to 4 other carbon atoms. Got my point? So it is your first carbon, second carbon, third carbon and fourth carbon. So carbon is linked to 4 other carbon atoms. That is why diamond has a rigid structure. Okay, so it is so tough, its structure is so rigid and it is so hard that it can be used as a cutting material or it can be used as a tip of the bore, the instrument or the equipment used for boring. And what else? Diamond is a non-conductor of electricity. Why diamond is a non-conductor of electricity? Because it doesn't have free electrons. See this structure. Does it have any free electrons here? No. So diamond is a poor conductor of electricity and its melting point is also very high. Why? Because of this linking. So diamond in carbon, the carbon is present in a tetrahedral form. Now let's take up the next question. Here, it is related to the allotrope of carbon. In graphite, carbon atoms are arranged in. How they are arranged in graphite? Or in graphite, what is the thing? I told you that in graphite, what happens? There are hexagonal layers of carbon atoms. So these are what? These are hexagonal layers of carbon atoms. Okay, so in graphite the carbon atoms are arranged in layers. So that is why, students, graphite is what? Graphite is very, very soft because these hexagonal layers can slide over one another. Now we've got this fifth question. What is it? Each carbon in graphite is bonded to dash carbon atoms. So each carbon is bonded to how many other carbon atoms? In graphite, each carbon atom is bonded to 3 other carbon atoms, that is 3. I'll draw its geometry properly, and this is linked to 3 other. Say that is 1 carbon above and 2 carbons like this. So there are 1, 2 and 3. So this particular carbon atom which is present at the center is linked to how many carbon atoms? 1, 2 and 3. So what would be its answer? It should be 3. Now this next question is, graphite is soft due to dash structure. Why it is soft? Because of this layered structure. This graphite is soft. Now why does it conduct electricity, students? This is because I told you that how many valence electrons are there in carbon atoms? There are 4 valence electrons. Now in graphite, each carbon is linked to 3 other carbon atoms. So what about that 1 electron which is not yet bonded? So what happens that this graphite has got a layered structure, that is there are hexagonal layers, right? Say there are graphite molecules here. Now what is there? Each graphite molecule has got one electron with it. See, this is which is not bonded. So what this can do? This electrons move from shell to shell. So because of this free electrons, graphites conduct electricity. Say if I'll try to complete an electrical circuit with the help of the pencil lid, that is which is black in color, will the circuit be completed? Yes, because it is a good conductor of electricity. Why? Because of the presence of free electrons. Or graphite, it is also used as a lubricant. Why it is used as a lubricant? Because graphite, it is used as a lubricant in machines. Why so? Because this graphite is non-volatile, and even at high temperature it doesn't convert into its gaseous state. So it is either mixed with petrol or it is used in its powdered form. As what? As a lubricant. Now let's move to the next question here. It's the same. Graphite is a good conductor of electricity because of the presence of free electrons. Its answer would be because of, we can say it as free electrons. Fine. Now what is our next question? Buckminster fullerene is composed of dash atoms. So what type of atoms are present in Buckminster fullerene? This Buckminster fullerene is an allotrope of carbon. So what type of atoms it is composed of? Carbon. Okay. So it is composed of carbon atoms. Now students, to find out what type of atoms are present in a particular compound, what is done is that the compound is burnt in oxygen. And whatever other products formed will decide the atoms present in that compound. So if I am burning this graphite here, so when graphite is burnt, what all other compounds formed? It forms carbon dioxide only. There are no residues left. Likewise, this Buckminster fullerene, when it is burnt in air, what gas is formed? It forms only carbon dioxide and no other residues are there. So it is composed of carbon atoms. Likewise, if diamond is burnt in air at very high temperatures, what is the product formed? It is again carbon dioxide. Okay, so Buckminster fullerene is composed of carbon atoms. Now this C60 is dash at room temperature. Now your diamond is a rigid solid at room temperature. Your graphite, it is an amorphous, or it is not that rigid, it is a soft structure. But this is in between diamond and graphite. Buckminster fullerene is neither very hard like diamond nor soft like it. So Buckminster fullerene is a mustard colored solid at room temperature. You know, it is amorphous in nature. Your diamond and graphite are the two crystalline allotropes of carbon. So it is not crystalline. Now this Buckminster fullerene C60 is made up of dash hexagons and dash pentagons. Now I have told you that when Buckminster fullerene is burnt in air, what are the products formed? It is the carbon dioxide only and no residues left. So what type of hexagons would be there? Carbon hexagons and carbon pentagons. So it has what? It is made up of 20 hexagons and 12 pentagons, right? And it is arranged in what type of structure? Such that the hexagons and pentagons are away from each other, and it forms a truncated icosahedron. Truncated icosahedron. These are arranged in the form of truncated icosahedron in such a way that the hexagons are placed away from the pentagons. And this gives it the structure like buckyball or the soccer ball structure. I discussed this in details in your theory session. Now the 11th question is, Buckminster fullerene dissolves in water giving magenta colored solution. Is it true, students? It is false. Buckminster fullerene is soluble only in organic solvents. Remember it. So it is soluble only in organic solvents like benzene or toluene. It is insoluble in water. Remember that only polar compounds or ionic compounds are soluble in water, or the compounds which can form hydrogen bond with water. Yeah, now comes your hydrocarbons. Write the structural formula of ethene. What is an ethene, students? I hope you know this. What is an ethene? I'll write it. E-T-H-E-N-E. What is the structure of your IUPAC name? It is root word plus the primary suffix. What this primary suffix tells us? This primary suffix tells the type of bond present between the carbon atoms. Okay, so what is the type of bond present between the carbon atom if the suffix is ane? So what is the type of bond? The single bond. Okay, and if the suffix is ene, like here, what is the type of bond? It is a triple bond. So what is the root word here? Eth. Okay, so it is framed of eth plus ene. Eth stands for 2 carbon atoms. So let's draw the 2 carbon atoms. Ene is for the double bond present between them. Now what is the valency of carbon, students? It is 4. So to how many hydrogen atoms it should be bonded? It should be bonded to 2 other hydrogen atoms, that is each carbon should be bonded to 2 other hydrogen atoms. Now this is the structural formula of ethene, this one. It is ethene. So likewise, if you are provided with any of the alkene, you first try to find out the root word there. Say, if I am saying propene or butene, okay, so butene. Now here what is the root word? But. But means what? 4. It means how many carbon atoms are there? 4. Ene means what? A double bond. And students, it's a single ene. It means there is only one double bond. If I am saying butadiene, what does this mean? This means that there are 2 double bonds. Okay? Now accordingly, in order to make carbon tetravalence, or in order to complete the tetravalency of carbon, put the respective hydrogen atoms here. Okay, so this all will be the hydrogen atoms. In your exams, don't forget to put the hydrogen atoms. Fine? So this is your ethene. Now what is our, next question, it is write the structural formula of ethyne. Again, so what is the name here, students? It is ethyne. Okay, so now what is the root word here? It is eth. What is the suffix here? It is "-ine". Now the root word is eth, means how many carbon atoms are there? There are 2 carbon atoms. How many bonds would be there? 3 bonds. 1, 2 and 3. Now in order to complete the tetravalency, how many hydrogens would be bonded here? It would be 2 hydrogen atoms. So it is what, students? It is ethyne. Likewise, if I have to make the structure of but-ine, so what does this 2 indicates? This 2 indicates the position of the triple bond. Now here, students, it's but. So how many carbon atoms? Now in this case it is 2-ine. Okay, so you count from any side, LHS or RHS. It would be 2 would be the similar one. Say that is 1, 2, 3 and 4. So what is this? This is but-ine. Now put the number of hydrogen atoms to complete the tetravalency. Now is the structure clear? Is this structure right? No. Yeah, this is right. This carbon has got 4 electrons and this has also got 4 bonds. So this is the structure of but-ine. But-1-ine would be CH, triple bond C, CH2 and CH3. This would be what? But-1-ine. So this was your second question. Now we have got write the structural formula of C4H10. So what was this question? Write the structural formula of C4H10. Structural formula of C4H10. Now in this case students, but before writing it, just try to find out whether it is an alkane or an alkene or an alkyne. So what is the general formula we are getting here? It is CnH2n plus 2, isn't it? Here N is 4 and H2 into 4 plus 2, and we will get C4H10. So it is an alkane. And what would be the name of this? How many carbon atoms are there? 4. So its name would be but. And what type of bonds are present between the carbon atoms? Single bonds. So it would be butane. Fine. Now how we will draw the structural formula of it? So this is carbon. 4 carbon atoms. Now complete its tetravalency. So this is H, 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 H. So this is the structural formula of butane. Now let's move back to our questions. So we have done this also. Let's move to the next question. What is the question here? Which of the following has a triple bond? How to find out this? How can we find out? Just try to write the general formula of the compounds given. Say this C2H4. What is the general formula coming out to be? CnH2n. Now in this case, this is the general formula for alkene. Okay. So, what type of bonds are present in alkenes? The double bonds. Now the next is, so this is not the right option. Okay. Now the next is C3H4. What is the general formula coming out to be? CnH2n minus 2, isn't it? Say N here is 3. So C3H, how much it would be? 2n, that is 6 minus 2. So what will be the thing? C3H4. So this is the general formula for alkyne. Now what type of bonds are present between carbon atoms in alkynes? It is triple bond. Fine. So what is the right answer? This. Now what about the next formula? That is, this is the first formula, second formula and the third formula. What is the next formula? C3H6. C3H6. So what is the general formula coming out to be? CnH2n plus 2, isn't it? Or it is CnH2n only. So what it is? It is again an alkene. So this is the way, students, you can find out whether the given structure has a double bond or a triple bond. That is, whether it is an alkene or an alkyne or an alkane. Had it been alkane, what is the general formula of alkane? It is CnH2n plus 2. So when it is C3, so H should be 8. Now this will give you the alkane, that is, it is a propane, right? Now let's see our next question here. So it is, which of the following has a double bond? Again you have to find this. Now let's check out. Molecule A, it is C4H10. So what is the general formula coming out to be? C4H4 multiplied by 2 plus 2. Or the general formula is coming out to be CnH2n plus 2. Okay? So what is it, students? It is an alkane. Fine. So this is an alkane. What is the name of this alkane? 4 carbon atoms are here, so it should be butane. Now what is the next structure? Next formula? C5H8. So what is the formula coming out to be? It is C5H8. So this is C5H2 multiplied by 5. You'll get 10. But what it is here? It's 8. So it is minus 2. Or the general formula is CnH2n minus 2. So what it is? It is an alkyne. 5 carbon atoms. So what would be its name? Pentyne. Okay? Now the next one, that is C5H10. What is the general formula is coming out to be? C5H2 multiplied by 5. That's 8. So CnH2n. So what it is, students? It is alkene. That is, it is pentene. That is, this is having a double bond. So what will be the answer of this question? Right? So students, these are the questions. These are the some of the or few questions related to the nomenclature of hydrocarbons as well as the allotropes. In our next session, we will be discussing about the questions related to the nomenclature only, IUPAC nomenclature. Thank you for listening patiently.